Good morning, dear student. In today's lecture, we will discuss the next cyclic pi system, that is cyclo C5H5 radical should be there. Cyclo C5H5 radical should be there. So this is looking like this. This is looking like this. So the double bond is there and one radical and remaining hydrogen is there. And we know that for the cyclic polyns, that is each vertex is corresponds to the relative energy of that molecular orbitals. So if you consider, this is the molecular orbit, this is the molecular orbit, that is, this is your psi 1, this is your psi 2, and this is your psi 3. So psi 1 having no node, psi 2 having one node, and psi 3 having two nodes. So we will see the presentation, p orbital interactions and the relative energies, that is the bonding, either it is bonding or non-bonding or it is anti-bonding. Okay, let's discuss it. The first one, that is this is your bonding interactions. So it is very simple, that is all p orbital in same phase, all p orbital of each carbon in same phase, they are in same phase, and which results into the bonding interaction. So this is your psi 1, there should be no node should be there, this is your psi 1, and two electron is goes here. So the two electron is goes here. The second, that is your psi 2. Psi 2, it indicate there should be a one node should be there. So how one node is possible? So the psi 2 having two, if you consider this psi 2 having two representation, because it has a two molecular orbital, two molecular orbital should be there. So they are having equal energy because they have same number of nodes. So psi 2 having two representation. So the one is that one is that the node, that is, this is the node which bisects the molecule into two equal halves. So this is the node. So if you consider, this is the node, so this is the node should be there. That is, if you consider the numbering, this is carbon number 1 2 3 4 and 5, that is, the node bisects the molecule passing through carbon number 1, that is, there should be a node should be there. And again, if you consider, this is the node which is passing from this carbon number 1. Again, if you consider, there should be a node should be there. So if you consider, this is your okay, let us consider this positive and then the blank is minus. Okay, so there should be a node should be there, because the node, it is present for this carbon number 1, carbon number 1 and carbon number 5. Similarly, it is present for carbon number 3 and carbon number 4. The node is applicable for carbon number 1 and 5, 3 and 4. And therefore, if you consider this representation which can consist of one node, so this is your bonding interaction, this is your bonding interactions, and this is also your bonding interactions. So this is your bonding, and this is also your bonding. So two bonding interaction in this case, two bonding interaction, as well as there is a two anti-bonding interaction. So this is the interaction, that is, one is positive, one is negative. So if you consider anyone, that is, the field one is your positive and the empty one is negative, then this is your anti-bonding interaction, anti-bonding interaction. And similarly, in this case, this is also your anti-bonding interaction, that is positive, negative, one is filled, one is empty. This is also your anti-bonding interaction. So there is a two bonding interaction plus two anti-bonding interaction, which results into a zero. means there is a no interactions. So the bonding interaction is cancelled by anti-bonding interactions. So there is a no interactions. So if you consider there is a total 5 electron is there. So 2 electron is goes here. So if you consider there is no interactions, no electron density is there. And the second one, that is if you consider the second one, that is if you consider the second one, which having a one node is there, this node is present, that is this node is like this, and it bisects the molecule, that is this node, it is perpendicular to the plane of the molecule. So if you consider this second pictorial representation, the first node is passing from the carbon number 1, and there is a 2 bonding and 2 anti-bonding interactions. So the no bonding interaction should be there. No, we can say that this is not a bonding interactions. Okay, either it is non-bonding interactions. Okay, either it is non-bonding interactions. So we can consider this as non-bonding interaction. Non-bonding interaction, and this is the node. If you consider this node is present, or this node it is applicable for this. If you see this, it is applicable for this carbon number 1, 2, 3, 4. Okay, this is applicable for 1 and 2, 3 and 4. So there should be a node between carbon number 1 and 2, carbon number 3 and 4. So how one can represent, that is like this. So if we write this, I will show like this. There should be a node, means there should be a field site is here, and there should be vacant site should be there. So this is your node should be there. Similarly in this case, there is a no node between carbon number 2 and 3. So I will fill here this is carbon number 3, and there is a node between carbon number 3 and 4, means I will write this, and this is your carbon number 4. So you should keep in mind, that is the node is present between carbon number 1 and 2, 3 and 4. There is a no node between carbon number 2 and 3, 1 and 5, and 4 and 5. So there is a no node, means the interaction is like this. So if you consider this pictorial representation, then this is your bonding interactions, this is your bonding interaction, this is your bonding interaction, this is your bonding and bonding. But if you consider this, that is the node, this is your anti-bonding interaction, and the carbon number 3 and 4, it is also having anti-bonding interactions. So total 3 bonding interaction and 1 anti-bonding interactions. So 3 bonding interaction minus 2 anti-bonding interactions. So there should be 1 bonding interaction. So 3 bonding minus 2 anti-bonding. So there is a 1 bonding interactions. So 2 electron is goes here. 2 electron is goes here. So if you consider, this is your first one, psi 1, there is a no node. So if you consider, we can write 2 electron here, that is 1 is bonding interaction. So this is the pictorial representation for this. And if you consider this, that is no interaction, no bonding interaction, 0 interaction, means this is your non-bonding. So the last electron, that is the 5th electron is goes here. The 5th electron is goes here, and this is your homo. This is your homo, and this is your lowest occupied molecular orbital, highest occupied molecular orbital, and the last one is psi 3. So psi 3, it having a 2 node. So how the 2 node is possible? So you should keep in mind, this is your psi 1, this is your psi 2. So psi 2, the first node is passes from carbon number 5, and the second node bisects the molecule which is perpendicular to the plane of the molecule. And if you consider this presentation, it consists of 3 bonding interactions and 2 anti-bonding interactions. So there is a total 1 bonding interactions. and therefore two electrons are filled and one electron is non-pointing. And if you consider the last one, that is the nodes, that is two nodes psi 3. So let us discuss for psi 3. The two node is present. So how this two node is present? So this is like this. So we know that this is your one node should be there, which is passes from carbon number 5, and this is the node which passes from carbon number 1 2 1 and 2 and 3 and 4. So this is the one representation for psi 3. This is one representation for psi 3, and the second one is that like this. I will draw like this. The node like this, the node is passes from this, the node like this, and this is like this. So node is present in this way. Nodal representation should be there. So the node is present between carbon number 1 and 2, and then 3 and 4. Okay, and similarly if you consider, it is also passes from carbon number 1 and 5 and carbon number 4 and 5. This is also the another representation for psi 3. So this is all about the cyclo C5H5 radical. So you should first draw the structure, find out the total number of electrons, and we know that the number of atomic orbital which is equal to number of molecular orbital. So in this cyclic Paulins, whatever the vertex is nothing but your energy of the pi orbital, pi molecular orbital. So we know that if we know the structure, then we can easily draw the energy level, and we can easily feel the electrons which is bonding interaction, which is anti-bonding interaction. So this is all about cyclic C5H5 radical. For homework, you try for the benzene, that is cyclo C6H6, cyclo C6H6. So it consists of total 6 electrons. So you try for benzene and find out the relative energy, which is your homo and which is your lumo for this cyclic C6H6. So if we consider the total 6 electrons cyclic, I will draw the structure and then you try for this. So there should be one hydrogen, 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 and we know that. So this is like this. So if you draw like this, so hydrogen, 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 and we know that one every vertex which is corresponds to the energy of molecular orbital. So this is your one vertex, then the two vertex having same energy, then another two vertex having same energy, and the next vertex should be there. And total, if you consider 2 4 6, 6 pi electrons should be there, 6 pi electrons should be there, and there should be like this interaction. So this is your psi 1, psi 2, psi 3, and this is your psi 4. Psi 4 should be there. Okay, so I will give this energy level diagram, relative energy for this benzene. You will try to represent the you will try to draw the pictorial representation for p orbital interactions for this benzene. Okay, in the next lecture we will discuss the remaining points of our syllabus. Thank you.